Hi everyone, welcome to this video. In this video, we shall discuss the chemistry section of JEE Advanced 2024 paper 1. If this is the first time you have seen the question paper, then I would recommend please pause the video, solve the question yourself and then come back and cross check your answer. So let's get started with the question number 1. A closed vessel contains 10 gram of an ideal gas at 300 Kelvin which exerts 2 atm pressure. So we can apply ideal gas equation. The question is the ratio of root mean square speed of gas X and Y. So now we know that RMS speed is under root 3RT by M. So basically RMS speed is inversely proportional to the molecular mass. So RMS speed of X and RMS speed of Y, it can be written as the molar mass of X and molar mass of Y. So the answer would be the square root of the molecular masses of Y and X. Now apply ideal gas equation PV is equal to RT to gas X. The pressure of gas X is 2 atm, volume is V, number of moles is mass upon molar mass which is 10 gram, the mass and molar mass let's say X. R is constant and temperature is also constant 300 Kelvin throughout the question. Applying ideal gas equation to gas Y, when gas Y is added the pressure becomes 6 atm. So the partial pressure due to gas Y is 6 minus 2 that is 4 atm. So again applying ideal gas equation 4 into V, the mass of gas Y is 80 divided by let's say the molar mass of Y is My and RT. Alright, now dividing these two equations, RT gets cancelled out, V gets cancelled out, and then we have 1 upon 2 is 0, 0 also cancels out. So this is we have My by 8mx. So basically the ratio of the molar masses of Y and X is 8 by 2 which is 4. When we plug in this value under root 4 here we get 2. So the correct answer is 2:1, that is option D. Moving to the next question, a very simple question from inorganic chemistry, reaction you can find in NCERT book. Nitrous acid HNO2 is an intermediate oxidation state of nitrogen. The range of oxidation state of nitrogen being from -3 to +5. So being an intermediate oxidation state, it will disproportionate. The products are, the oxidation product is nitric acid and the reduction product is NO, nitric oxide. So the correct answer to this question is option A, right? As HNO3 will dissociate in water to produce H3O plus and NO3 minus. So these being the three products, right? H3O plus, NO3 minus and NO. Moving to the third question. Again, a simple question from Chemistry in Everyday Life chapter. You can find this in NCERT book as well. Aspartame, an artificial sweetener, is a dipeptide aspartyl phenylalanine methyl ester. So the key to this question is that the ester linkage is formed by the carboxylic group of phenylalanine, not the aspartic acid. All right. So phenylalanine, they have given the structure. So phenylalanine will change to COOCH3 as it is a methyl ester, right? Now you can see in this option C, they have formed ester with aspartic acid, right? You can see here the 2 carboxylic acid and aspartic. That rules out option C as the correct answer. And also option D. In option D, again, they have formed ester with the aspartic acid, right? NH2, COCH3 and this, right? So option C and D are ruled out. Okay. Now let us come to option A and B. All right. So we write the N terminal on the left here. So NH2, CH here, CH2 here, and COH. So this is the aspartic acid moiety, right? NH2, CH, CH2, carboxylic acid, and this is the peptide linkage. Now you can see from phenylalanine to this, the configuration of this benzyl group has changed, of course, because here the benzyl group was pointing in the front, right? And if you want to form the peptide linkage, you will have to flip this molecule, right? 180 degree. So NH2, which was like this, it will be now like this to form the peptide bond, and the pH CH2 linkage, which was pointing in the front direction, it will come on the backside direction. All right. So the correct answer to this question will be option B. Let's move to question number 4. Among the following options, select the option in which each complex in set 1 shows geometrical isomerism and the two complexes in set 2 are ionization isomers of each other. So that rules out option A as the correct answer because NiCO4 is tetrahedral and tetrahedral molecules do not show geometrical isomerism, right? Moving to option B, COEN NH3 twice Cl twice will show geometrical isomerism. So set 1 satisfies the criteria. But in set 2, if you observe, they are not the ionization isomers. They are coordination isomers because the ligands are exchanged between two different coordination entities. That rules out option B as the correct answer. Moving to option C, yes, this is the correct answer to this question because CONH3 NO2 that is, it's a complex of type Ma3B3, and yes, it shows facial meridional isomerism, which is a type of geometrical isomerism. The other complex is COEN twice Cl twice. Yes, the 2-chlorine can be either cis or they can be either trans. All right. In set 2, yes, linkage isomers are formed when a counter ion is exchanged with a ligand. So in the first molecule, sulfate ion is acting as a counter ion. In the second molecule, it is acting as a ligand. So both set 1 and set 2 satisfy the criteria as per the given question. So that is the correct answer. Moving to section 2. Question number 5 is a very easy question. Among the following, the correct statements for electron in an atom is are. Uncertainty principle rules out the existence of definite paths for electron. Yes, correct. Because Heisenberg uncertainty principle states that it is impossible to determine the exact position and momentum of a microscopic particle simultaneously, so we cannot determine its trajectory, that means its path. Moving to option B, the energy of an electron in 2s orbital of an atom is lower than the energy of an electron that is infinitely far away from the nucleus. We know that the energy of an electron is given by minus RH z square by n square. So from this expression we can see that the energy of a bound electron is negative. Yes, and if you put n is equal to infinity, the energy comes out to be 0. So the energy of a free electron is 0 and the energy of a bound electron is negative, which is definitely lower than 0. So the option B is also correct. According to Bohr's model, the most negative energy value for an electron is given by n is equal to 1. Correct, right? Because energy is directly proportional to the magnitude of energy is directly proportional to the value of n, right? Because there is a negative sign and there is an inverse for n square, right? So if n is 1, so this number is going to be largest, and due to negative sign, it is going to be most negative. So we know that for hydrogen atom, the ground state energy is minus 13.6 electron volt, which is highest in magnitude, right? Or you can say most negative. So option C is also correct. Option D, according to Bohr's model, the magnitude of velocity of electrons increases with increase in values of n. That is not correct because the velocity of electron is approximately 2.2 into 10 raised to the power 6 meter per second multiplied by z by n. So as the value of principal quantum number increases, the velocity of electron decreases. So the correct options are A, B and C. Question number 6. This question was from organic chemistry and yes, its level was moderate. Reaction of isopropyl benzene with oxygen followed by treatment with acidic hydrolysis forms phenol and acetone. This reaction again is an NCERT, a very famous industrial preparation of phenol, right? So let us discuss its solution. This is isopropyl benzene. In common system, we call it cumene. If you react it with oxygen, it forms cumene hydroperoxide. You can find the detailed equation in NCERT book also. And then when we do the hydrolysis, it produces phenol and acetone, an important byproduct. So this is phenol and this byproduct is P. Now if P is reacted with 3 equivalents of chlorine, so 3 equivalents of chlorine, that means chlorination, right? And that will give us CH3, C double bond O and CCl3, right? All alpha hydrogen of one methyl group will be replaced by chlorine because we have 3 equivalents of chlorine. So that gives us compound Q. Treatment of Q with calcium hydroxide produces R and calcium salt S. Now, if you will react with hydroxide, so what happens? Hydroxide attacks here, the pi bond breaks. That gives us CH3COO, CH3CO minus, OH and CCl3. When this back shifts, CCl3 minus departs, being a good leaving group. So now we have CH3, C double bond O, OH and CCl3 minus. Now because CCl3 minus is a strong conjugate base compared to carboxylate, so there is a proton transfer here and we get CH3CO minus and chloroform. Let's come back to the question. Treatment of Q, which is this, with calcium hydroxide produces R and calcium salt S, right? So this will be CH3 CO twice and calcium, right? The correct statements regarding P, Q, R and S are. Let's see the first statement. Reaction of P with R in presence of KOH followed by acidification gives. So the P is acetone, right? R is chloroform and in the presence of KOH. So when you react chloroform with KOH, obviously OH minus is a base and chloroform is acidic. So the reaction of chloroform with KOH will yield you CCl3 minus, which will act as a nucleophile to P, that is acetone. So when this reacts with acetone, it is a nucleophilic attack again, and you will get CH3CO minus, CH3 and CCl3 followed by acidification. So when we acidify it, O minus accepts a proton and this is your product. This is called chlorotone, and yes, this is the same molecule, CH3 CH3 OH CCl3. Option A is the correct option. Reaction of R with oxygen in the presence of light gives phosgene gas. Yes, chloroform when oxidized by oxygen in presence of light, it gives phosgene gas and HCl. You can find this reaction in NCERT in haloalkanes chapter, so that is also correct. Reaction of Q with aqueous NaOH produces CH2CH and trichloroacetate. This is not correct because Q is CH3COCl3 when you react it with NaOH. So it will show the similar reaction as calcium hydroxide and it will form acetic acid and chloroform. Last, S on heating gives P. Yes, calcium salts of carboxylic acid when distilled they produce carbonyl compounds. So a way to understand this is the structure. This is how we can write calcium acetate. When we distill it, that is heated, a molecule that is calcium carbonate, it departs and that we get CH3COCH3, which is acetone. All right. So the correct answer is P. So that is also correct. So in this question, the correct statements were A, B and D. All right. Moving to the next question, a very easy question. The options in which at least three molecules follow octet rule. Octet rule says that atoms combine either by sharing of valence electrons or by transfer of valence electrons in order to have 8 electrons in their valence shell. Now, there is a kind of catch in this question because it contains hydrogen also, and hydrogen obviously cannot have 8 electrons in its valence shell. But anyway, see, this question is very easy to do if you notice that there are molecules of type NO and NO2. They have odd electron. Nitrogen contains 7 valence electrons, so they do not obey octet rule. So this will not obey octet rule. This will not obey octet rule. They will not obey octet rule, right? BCl3 will not obey octet rule because it forms 3 covalent bonds and there are a total of 6 valence electrons. Alright. H2SO4 does not obey octet rule because sulfur forms more than 4 covalent bonds in the stable structure. We all know the structure of sulfuric acid is this. Sulfur forms 6 covalent bonds, so there are a total of 12 valence electrons. So H2SO4 is also ruled out. So the options in which at least 3 molecules follow octet rule is option A and option D. CO2, C2H4, HCl and CO2, ozone and C2H4. Moving to the next question. An easy question, I would say, from thermodynamics. Consider the following volume temperature diagram for the expansion of 5 moles of an ideal monatomic gas. The question is, what is the total enthalpy in joule for the transformation of state from X to Y to Z? A very easy question, guys. From X to Y, it's an isothermal process. The temperature is constant, 335 Kelvin. Now we know that delta H is delta U plus R delta T. For an ideal gas, if temperature is constant, delta U is 0 because internal energy is a function of temperature only. Delta T is 0, which means delta H is also 0, right? So for this process, X to Y, delta H is 0. Now from Y to Z, temperature is increasing but volume is constant. So here we can use delta H is N CPm delta T. Alright. Cp is a molar heat capacity at constant pressure, which is Cv plus R. A very easy substitution will give you the answer. Number of moles is 5. Cp is Cv plus R, which is 12 plus 8.3, that is 20.3, multiplied by temperature difference 415 minus 335, which is 80. If you do the calculation, you will get the answer is 8120 joule. So that is the answer to this question. Moving to the next question. Again, I would say an easy question from chemical kinetics. If you have studied chemical kinetics, you would remember doing this sort of question. We determine the rate law for a complex reaction from its RDS, which is the slowest step, right? So from this step, we can write rate law as the rate constant, which is K2, and the two species are N2O2, the dimer of nitric oxide, and hydrogen gas. Now, any species that appears in the rate law must appear in the overall chemical equation. You can see here N2O2 is nowhere in the overall balanced equation. So we have to substitute this. Where does it occur in the mechanism? In the first step. So let us write the equilibrium constant for first step. Kc is N2O2 square divided, N2O2 divided by NO square, right? So N2O2 can be substituted K2, Kc of first step, N2O2 can be substituted as NO square and hydrogen. The order of the reaction is the sum of the exponents of the concentration terms, which is 2 plus 1, that is 3. Alright, so the answer to this question is 3. Question number 10. Complete reaction of acetaldehyde with excess formaldehyde. This is a very important reaction, guys. We studied this in aldol condensation and Cannizzaro reaction. Acetaldehyde has alpha hydrogen, CH3CHO. These are 3 alpha hydrogen. Formaldehyde does not have alpha hydrogen. Now, when you react a mixture of acetaldehyde and formaldehyde with concentrated NaOH, first the base removes a proton, CH2CHO. It attacks formaldehyde. This is a nucleophilic addition, right? And this gives you CH2O minus, and this is CH2CHO. Upon acidification, it gives you OH. All right. Now the question is excess formaldehyde. So obviously this is your carbonyl group and there are still 2 alpha hydrogen left. So these steps will repeat. Alpha hydrogen will be removed by base. That carbanion will attack formaldehyde, and these 2 alpha hydrogen that you can see here, they will be replaced by CH2OH group. Alright. So what we will get is this. CH2OH, CH2OH, and CH2OH. Alright, there was one CH2OH before, and 2 CH2OH groups will be introduced by the reaction of 2 equivalents of formaldehyde. Now you can observe there is no alpha hydrogen here. Now if this molecule is subsequently reacted with formaldehyde, right, and there is a concentrated NaOH in the system, it is a Cannizzaro reaction. Formaldehyde being more reactive will undergo oxidation and the other molecule, which is this, in this case, will undergo reduction. All right. So this reaction between formaldehyde and this molecule, it will give us CH2OH, CH2OH, CH2OH. This will undergo reduction, so it will be CH2OH, and plus this will be HCO minus, right? Compound P does not give tolerance test. This is a compound P. Alcohol does not give tolerance test, whereas Q on acidification. This on acidification gives formic acid, and yes, formic acid gives tolerance test. It is oxidized to CO2. So this is our Q. Treatment of P with excess of cyclohexanone. So you can see, guys, this is a compound with multiple OH groups. If you react it with cyclohexanone, this is a ketone, this is alcohol. You remember what is the reaction between aldehyde ketone and alcohol? Yes, it is acetal and ketal formation, which are used as protecting groups. All right. So what happens? Let's say these two OH will react with one cyclohexanone molecule, and these two OH will react with another cyclohexanone molecule. So the compound formed here would be this, and the other two oxygen atoms will react with the second equivalent of cyclohexanone. For your clarity, I'll highlight this. This much is this molecule. All right. Okay, so this is one ketal linkage and this is another ketal linkage. Now the question is sum of the number of methylene groups and oxygen atom. You can count, there are oxygen atom as 4 and methylene groups is CH2. So this is 1, 2, 3, 4, 5, 6, and this is of course like this. Okay, so this is 7, 8, and this 9, 10, 11, 12, 13, 14. So this is 14. So the correct answer is 18. All right. Question number 11 is indeed a very easy question if you observe. The total number of species isoelectronic with NiCO4. All right. You can see all these metals are from the first transition series, which is 3D series. Obviously, the maximum difference in the number of electrons can be 9, right? Because they run from D1 to D10. So any metal carbonyl that does not have 4 carbon monoxide molecule cannot be isoelectronic with this. All right. I mean, this I'm saying on the basis of given options. Okay. Right. For example, you can see, let's say pick this complex. It has 3 carbonyl groups, so one less than this, right? So the number of electrons in carbon monoxide is 6 plus 8, that is 14. Now, obviously, copper cannot have 14 electrons more than nickel, right? I hope you're getting my trick here because it's very easy to observe. Iridium is 77. Its number of electrons are way higher than the number of electrons in nickel, right? So that also cannot be isoelectronic. That only leaves us with this, right? Both NiCO4 and CrCO4 4 minus have 4 carbon monoxide. So we just need to check the number of electrons on the metal. Number of electrons on nickel is 28 and the number of electrons on chromium is 24. Its atomic number, and 4 minus, that is it has gained 4 electron, that is 28. So there is only one complex that is isoelectronic with NiCO4. The correct answer being 1. Let's move to the next question. Again, a moderate level question from organic chemistry, but not a difficult one, I would say, right? So this is a molecule given to you. I'll write it like this. There is a triple bond here, right? This is a triple bond, and there are 15 methylene groups, and then there is ethyl ester linkage. First reaction is the hydration in presence of mercury. This is very famous hydration of alkynes, which is a Markovnikov addition. That will give us CH3, C double bond O, and the entire molecules remains like this, right? So we will first discuss this part. When you reacted with zinc amalgam and HCl, this is again a popular name reaction, Clemmensen reduction. It will reduce CO group to CH2. All right. Earlier there were 15 CH2 groups. Now a new one group has come, right? And also the third step is hydrolysis. Hydrolysis will get rid of ethyl group and this will convert to carboxylic. So the P molecule, which is very crucial molecule, is CH3, CH2, 16, and then COH. I hope it is clear, right? CH2 15, methylene groups are already there, 16 we have got it, and this is this molecule, this is P. Now glycerol reacts with P. This is a carboxylic acid, glycerol is an alcohol, so of course you will get an ester. Alright, so ester of this kind, CH2 16 CH3, and this moiety will repeat. Okay, this moiety will repeat in the second and third oxygen linkage. So it will be same CO CH2 16 CH3, and here also CO CH2 16 and CH3. All right. Now reaction of Q, this is our Q, with NaOH. So now we are doing the reverse process, that is called saponification, right? Ester hydrolysis in alkaline medium, followed by treatment with calcium chloride yields calcium soap R. So when you hydrolyze molecule Q, all these carboxylate moieties get separated, right? And with calcium chloride they form soap. So the formula of soap would be CH3 CH2 16, and then here is ester linkage also, sorry, carboxylate linkage also. This is CO twice and calcium. So I hope you guys are getting, because when you do the saponification of this carboxylate will separate as CH3 CH2 16 CO minus, right? So they will form soap with calcium chloride. Now, starting with 1 mole of Q, of course, if you start with 1 mole of this compound, you will get 3 moles of these ions. And because they combine with calcium, right, and calcium has a valency of 2, so the calcium consumed will be 1.5 mole, half of that, right? So the total mass you can calculate. Calcium is 1.5 mole, so 1.5 into 40, that is 60. And you can calculate the mass of this, right? There are 16, 17, 18 carbon, so 18 into 12, plus there are 16 into 230, 2 plus 335 hydrogen, and there are 2 oxygen, so 2 into 16. You can calculate that, that will come out to be 283. So 283 multiplied by 3. So that will come out to be 909. Indeed a lengthy question, but logic wise not very difficult. Yes, but lengthy question. Next question, to compensate, they gave an easy question. Among the following complexes, the total number of diamagnetic species. So first you've got to see the d orbital configuration of the central metal in all these complexes. Manganese is 3d5, right, 4s2, and iron is 3d6, 4s2. Cobalt is 3d7, 4s2, and again, yeah. So in MnNH3 6 3 plus, the oxidation state of manganese is 3 plus, so it is 3d4. So the d orbital configuration looks something like this. The coordination number is 6. For 6 coordination number, the hybridization would be d2sp3. That means we only need 2 d orbitals. So we will pair only 1 d electron. We will not waste energy in pairing up a d electron, and for which we also don't need the d orbital, right? So this electron is paired here, and you have 2d orbitals available. Hybridization can be done. So this is not diamagnetic, as there are 2 unpaired electrons. Chloride is weakly ligand. It will not even pair electrons. It will be an outer orbital complex. So all the 4 electrons of 3d orbital will remain unpaired, giving it a paramagnetic nature. Fluoride is also a weak field ligand. It will not involve inertial d orbitals. Again, the iron is in +3 state here, and 3d6 4s2 converts to 3d5. So all the 5 electrons of iron will remain unpaired. Fluoride, again, weak field ligand. It will not pair up the electrons of cobalt. Here the oxidation state of cobalt is 3, and 3d7 4s2 converts to 3d6. So it will have, you can see the d orbital configuration, 1 2 3 4 5 6. So there are 4 unpaired electrons. All right. FeNH3 6 3 plus. FeNH3 6 3 plus, again the oxidation state of iron is 3, which is 3d6 4s2 converts to 3d5. Again, because there are 5 electrons, they cannot be paired up. It will be paramagnetic. coming to the last, it has to be our answer. Otherwise, the answer would be 0. So cobalt is 3d74s2. 3 plus will form 3d6. Yes, now if we have 6 electrons, all will be forced to pair up like this. You can see 1, 2, 3, 4, 5, 6. Now you have 2d orbitals available and d2sp3 hybridization can be done. So the total number of diamagnetic species is only 1. So that is the correct answer to this question. Moving to the next question, that is section 4. This is good that they have given the limiting ionic conductivities because that makes this question very easy to solve, right? There are 4 conductometric titrations and you have to predict how the conductance will vary when the titrant is added dropwise. Titrant is something which is added to the titrate dropwise from outside. In the first case, the titrate is KCl. Okay, so you should see how this question is to be approached. So the conductance is due to K plus and Cl minus. We are ignoring conductance due to water. All right. As per the given table, the conductance of K plus ion is 7.4 and the conductance of chloride ion is 7.6. The titrant is being added, that is silver nitrate. When silver nitrate is added, of course, a precipitation reaction occurs. You might be familiar with this. AgCl is precipitated. When AgCl is precipitated, you can see now the system contains K plus and NO3 minus. Alright, AgCl plus AgNO3 plus KCl gives AgCl plus KNO3. So KCl in the system is being replaced by KNO3. Or in short, chloride ion is being replaced by nitrate ion. Okay, chloride ion is being replaced by nitrate ion. Now in the table you check the conductivity of nitrate ion, that is 7.2. There is not much difference, right? The conductivity of chloride is 7.6, that of nitrate is 7.2. So there will be a slight decrease in the conductivity. So that gives us option 2 and option 3 can also be there, and option 5 cannot be there because after all the AgCl has precipitated, now addition of AgNO3 will increase conductance. So option 5 cannot be there. Option 2 can be valid and option 3, but option 3 seems more likely because when nitrate replaces chloride, the decrease in conductance will not be much, right? It will be 0.4. Okay, but we'll not take our chances and let us focus on option 2 and option 3. Okay, so P matches with option 2 and option 3, so that means option B or C, one of these has to be the correct answer. All right, one of these has to be the correct answer. Now let us check option Q. This time titrate is AgNO3. All right, this time titrate is AgNO3. So the conductance of Ag plus is 6.2 and that of nitrate is 7.2. Titrant is KCl, so you are adding KCl. Now the reverse reaction happens, as in now AgCl is precipitated, right? And this time in the system, again, you are left with K plus and NO3 minus. Okay, so basically Ag plus is being replaced by K plus. I hope you guys get it. Ag plus and Cl minus are precipitating and K plus is replacing Ag plus. So the conductance of K plus is 7.4. Conductance of Ag plus was 6.2. Conductance of K plus is 7.4. There will be slight increase in the conductance. What we can see here is that it might match with option 4. So Q might match with option 4. Of course, both are given as option 4. They are smart guys. Now let's go to R. This contains NaOH. Conductance is due to Na plus and OH minus. The conductance values are Na is 5.0 and OH minus, it shows high conductance due to proton transfer mechanism 19.9. When you add HCl, what happens? Neutralization. H plus and OH minus, they combine to form water whose conductance we can ignore, a very weak electrolyte. So in short, OH minus is being replaced by Cl minus. The conductance of Cl minus is 7.6. Now you can see a large difference in the conductance. So when HCl is added to NaOH, OH minus ion is being replaced by chloride, conductance will decrease sharply. So that gives us option 2, right? It might match with option 2. So R might match with option 2. That gives us option C, but also let us check S if it matches with 5. Okay, In S, the titrate is again NaOH. Conductance is due to Na plus and OH minus. When you add acetic acid, again H plus neutralizes OH minus and OH minus is replaced by acetate ion. Looking at the conductance values, Na plus is there is no change, so we don't need to see. Hydroxide is 19.9 and acetate is 4.1, a large decrease in the conductivity. So the conductance will decrease. Now, when the entire NaOH is neutralized, now if you add acetic acid beyond the endpoint, the conductance will not change appreciably because acetic acid is a very weak electrolyte. So yes, S matches with 5. So that gives us option C as the correct answer. P3, right? The slight decrease followed by increase. QR, Q will match with 4, slight increase, and then, again increase. R matches with 2, slight decrease, and then increase, and then S matches with 5, right? Sharp decrease from 19.9 to 4.1, and then almost there is no change. So that is the correct answer. This is a very easy question based on VSCPR model, right? You know how to draw the structures of XeF2. There are 8 valence electrons, right? 2 will be distributed with fluorine and 6 electrons will remain, so that will give us 3 lone pairs. All right, so the correct answer to this will be, you can guess, XeF2 is trigonal bipyramidal with 3 lone pairs of electrons, so that matches with 5. So out of option A and B, there is a correct answer. Now let us see Q. Q is XeF4. There are 8 valence electrons, 4 are shared with fluorine. So this gives us the configuration, and 4 electrons form lone pairs. So geometry is octahedral, right? And there are 2 lone pairs of electrons. So it matches with 3. Q matches with 3. So option B is the correct answer. But let us see other option also. R matches with 2. Does it? Yes, xenon trioxide is this. 8 valence electrons, 6 are distributed with oxygen. There is 1 lone pair. So tetrahedral with 1 lone pair of electron. XeO3 you have 2. More electronegative atom will remain on axial position, Bend's rule, and 3 oxygen will remain on the equatorial position. So S will match with 4, trigonal bipyramidal with no lone pair of electrons. So the correct answer is option B. Let's move to question number 16. Yes, indeed a very lengthy question, right? So in such questions, you should first observe the question and try to figure out, is there a shorter way to answer this question? So how did I discover? If you do option P, right, and option S, then you can figure out the answer out of this, right? So let us first see option P. Okay, by the way, the correct answer to this question was option A. All right, so let us see in the first P. This is cyclohexene. First reaction is ozonolysis. So this is aldehyde, right? When you reacted with aqueous NaOH, this is intramolecular aldol condensation. So let's say we remove H plus from here and attack here, right? So that gives us a 5-membered ring with CHO as a side chain, and the next carbon is OH. If you heat it, dehydration occurs on alpha beta position, and we have CHO this. Next reaction is hydroboration oxidation, which is anti-Markovnikov, right? Boron BH3 approaches from the least sterically hindered site, and that is this. All right. Then you hydrolyze this H3O plus, right? Okay. I think from after aldol condensation, you reacted with ethylene glycol, so that is again acetal formation, right? So when you get this and the double bond, then you reacted with ethylene glycol, right? I missed this part. Then you react it with hydroboration oxidation, right? Again, this is the double bond and the boron is bulky, so it will attack from here, right? And this will be the ketal and not the, right? And here also there will be a double bond here and then CH. Then After you hydrolyze this, right, you get OH and then this is CHO, and if you reduce it with NaBH4, then you get OH and then CH2OH. You can see the correct answer is this, right? Cyclopentyl, there is OH and then there is hydroxymethyl group. All right. Then coming to option Q, the sequence is same, right? First you do the ozonolysis. So this is COCH3 and this is CHO. Next is aqueous NaOH. So again, intramolecular aldol condensation. Now you have to see the stability of the ring, the reactivity of carbonyl group, right? So out of ketone and aldehyde, which is more reactive? Aldehyde. So nucleophilic attack will happen on this, and the carbonyl enolation will be formed by this, right? So this will attack on this carbonyl carbon. So that will give us 1, 2, 3, 4, 5 membered ring. 5-membered ring we have. All right, so this will convert into CHO minus, and then 1, 2, 3, 4 methyl will be there. 1, 2, 3, 4 methyl will be there, and this will be C double bond O CH3. All right, again the same sequence. You are heating it, so this O minus goes, and there is a double bond here. Then the reaction is with ethylene glycol in the presence of PTSA, which is para-toluene sulfonic acid, right? So that will form the ketal. All right, and then after ethylene glycol, again you carry out the hydroboration oxidation, anti-Markov addition of water. So boron approaches from this side. So we'll remove this, and there is OH group here. Then we hydrolyze this. It comes back as keto, right? And then the reaction with NaBH4 produces secondary alcohol, right? So this is OH and this is OH and CH3. So I hope you guys got this. So Q matches with 5, right? Cyclopentyl, there is OH on adjacent carbon, there is CH, CH3, OH. Similarly, you can match all the other options. For example, this ethylene glycol, it will form a ketal, all right? Then it is oxymercuration demercuration, right? That will form a Markovnikov addition of water. So double bond will disappear. You will have OH here, and then hydrolysis. This will form again ketone and then reduction. So basically, this will be OH, and this is CH3, and this is OH. All right. So R will match with option 4. It's right here. Okay. So S has to match with option 1. Let us see. Ethylene glycol, you form the ketal. All right. Then hydroboration oxidation. Now this is which is this. All right. Then hydrolysis, keto will produce back, and then reduction. So basically that will give you OH, CH3, and then OH. That matches with the option 1. 1 methyl group flanked by 2 OH groups. So the correct answer is option A. Moving to the last question of this paper, these two were indeed very lengthy question from organic chemistry and must have taken up a lot of your time, right? So when there's a difficult question, you need to calm down. It really sometimes is not very difficult. What you have to do is just be careful, right? And do not miss any small point. In this question, I'll tell you straight off the correct answer first. The correct answer is option C. All right, correct answer is option C. So P is very easy. Sulfonic acid on reaction with molten NaOH followed by acidification forms phenol, and phenol on reaction with HNO3 it forms picric acid. So P matches with 3. All right, so this is picric acid 2,4,6 trinitrophenol. All right, and again S is very easy. If you had done C, P matches with 3, so that gives us out of option C and D as the correct answer, one of the two, and then you can check S, right? That's how I approached this question, right? S, 1 and 4, let us match S. So this is toluene. When reaction with KMNO4 is done, it oxidizes this toluene to COH. All right, now, if you do the nitration in presence of conc HNO3 and H2SO4, COH is an electron withdrawing group. So nitration is done at meta position. All right. Then reaction with SOCl2, it will change it to COCl group. Then reaction with amide, ammonia, it will change to amide. And then when you react it with Br2 NaOH, it is Hoffman bromamide degradation reaction. It will remove this CO group here, right? So what you will just have is NH2. All right. So you will just have NH2 group here. That is the aniline moiety. Then you carry out the diazotization. You know that diazotization will give you the N2 plus, and reaction with H2O produces phenol, the corresponding phenol. So basically this will give you OH, NO2, NO2, right? So yes, S matches with 1, right? We have OH and 2 NO2 at metaposition. Similarly, you can do option Q and R. Q will match with 5 and R will match with uh, Q will match with 5 and R will match with 4. All right. So that's all in the solution. Thank you for watching till the end. Subscribe to this YouTube channel, and if you know someone who is preparing for JEE Advanced in 2025 or will be writing the exam in 2026, please share this with them. It might be helpful for them. Thank you.